Hey everyone, thanks for your time. In this news update, we'll look at the continuing uncertainty in the outlook for SLS production, dig a little deeper into questions about the low Earth orbit Artemis III alternative, and go through the Government Accounting Office's annual assessment of NASA's major projects, in particular the Artemis programs. And also finally, we have a more realistic graphic of what the exploration upper stage is going to look like, which is more like the other upper stages that pull deep space duty. A few weeks ago, I put out a video wondering what the future of SLS was. This week, I got a response from NASA to those questions, but the uncertainty remains in full. Right now, NASA has contracts to build different parts of SLS for different numbers of launches. The constraining contract is for the two liquid propellant stages, the core stage and the exploration upper stage, and right now only 4 full SLS vehicles are covered. A transitional contract called the Pre-Exploration Production and Operations Contract Evaluation and Readiness, or just pre-EPOC for short, was supposed to be awarded by now as the spring ends and summer begins in 2024. However, there's been no announcement of either an award or an explanation of the current situation. The questions I asked NASA at the end of May were, number 1, are negotiations on pre-EPOC still in progress? Number 2, does NASA still anticipate that pre-EPOC will start by the end of the spring, which is imminent, which we already kind of have an answer for now? And number 3, if not, is there a new estimated date for either contract negotiations for pre-EPOC to be completed or a new estimated date for a change in acquisition or contract strategy? Here's the 3-sentence response. The first sentence says, quote, NASA is evaluating efforts to move towards a services-based contract model to reduce the costs of producing rockets for Artemis missions under the Exploration, Production, and Operations contract. The second and third sentences reiterate information contained in the original announcement of pre-EPOC over a year ago. That includes the sole source selection of the Deep Space Transport joint venture between Boeing and Northrop Grumman, and the responsibilities that joint venture would have if and when both contracts were signed, first pre-EPOC and then eventually EPOC itself. So here are some possible takeaways, since the response does not address the questions about the status of negotiations or timing. First, the second and third sentences are reiterating previously known information, but it suggests that EPOC and deep space transport are still things. The negotiations aren't mentioned at all, but it also doesn't say they are dead. Given the reluctance to say anything definitive, it seems like an award of pre-EPOC is delayed some indefinite period of time. And it's hard not to wonder, is anybody getting cold feet? Are Boeing and/or Northrop Grumman, both public companies who have recently suggested their own reluctance to pursue firm fixed-price contracts, are they maybe considering whether they want to assume the majority of the cost and performance risks of that contract? Inserting this pre-EPOC evaluation period in front of the EPOC award was already the result of NASA re-evaluating their EPOC strategy. Are they now re-evaluating the pre-EPOC strategy? So we're now at the halfway point of 2024 and this pre-EPOC award has not occurred yet. And there's no clarity on either when an award might happen or whether an award will happen at all. Yet another big picture watch item to keep an eye on. It makes sense to step back and wonder, does this matter? And it does. It at least matters to the already uncertain Artemis schedule. An indefinite delay increases the likelihood of more delays to Artemis missions that rely on the production of SLS vehicles. It also increases the likelihood that any cost savings from adopting a commercial services model will be delayed farther into the future. So progress down the path to sustainability or affordability would seem to be delayed for however long this situation remains unresolved. Some production of the 5th SLS core stage has been authorized under undefinitized contract actions, but it's not clear how much production. And an exploration upper stage for Artemis V will also be needed, and it's not clear how much production of that has been authorized yet either. Along the same lines of the uncertain plans for the future of SLS, Aviation Week reported a note on Boeing's SLS landing page and confirmed that the company did not bid on the National Security Space Launch, or NSSL, Phase 3 procurement. Initial Lane 1 awards for that were recently announced. Irene Klotz with Aviation Week reported in early March of 2023 that Boeing was interested, but given the uncertainties about future funding and production plans, it's not hard to see other considerations besides interest. Although not bidding is not something that is typically broadcast, it was still a curiosity to see that note buried on a landing page. The timing was curious too, but after this latest report from Aviation Week, I went and checked to see if the Wayback Machine had any cached copies of the page, and what's interesting is that, if the cached information is accurate, Boeing put this paragraph saying they would not participate in the NSSL Phase 3 procurement on their landing page only a few weeks after their original statement in March 2023. According to the Wayback Machine cache, that paragraph with Boeing's statement saying they were not interested in NSSL Phase 3 was online by March 28th of 2023. I missed that for a long time, but turning it down 15 months ago, shortly after the request for proposal was released, is another wrinkle in this storyline. Given that Boeing continues to produce study concept papers and even submit bids for things like alternate Mars sample return concepts, they are still interested in finding a customer outside of Artemis for SLS. But they didn't win a small award to continue studying their concept for Mars sample return that would be launched by SLS Cargo. And these long-standing questions about production and affordability have to factor into how competitive an offering the vehicle is right now. Another uncertainty watch that continues is with plans for Artemis III, which 5 years ago became a crewed lunar landing mission and the agency's top priority under the Trump administration. The administration advocated to Congress that they shift from flat funding Orion and SLS to the front-loaded R&D funding curve that emphasizes speed. Because policy was changed to make the top priority not just a crewed lunar landing, but it must also be achieved by the end of 2024. Congress did not agree to that kind of funding curve or diverting funding by terminating SLS upgrades, but NASA's policy was already set and the 2024 goal remained there with a lower level of financial commitment. When the new Biden administration came in, they made no significant policy changes, since what's in place is a hybrid of priorities from Congress and the past two presidents. But the 2024 goal was unrealistic when it was made, despite publicly stated confidence in that deadline and then subsequent dates. Or, to put it another way, the Artemis III dates were aspirational. Artemis III at the end of 2024 became Artemis III at the end of 2025, and now it's September 2026. I've gone over the lack of dates and the lack of listed interim milestones for Axiom, Orion, SLS, and Starship, and some of the watch items for those, but beginning about a year ago, we heard NASA talk about alternate mission possibilities. Orion and SLS have been aiming to have the third Artemis hardware set ready closer to when the second set flies with Artemis II for a while, so NASA has planned for a while to try to fly Artemis III no more than 1 year after Artemis II. With the Artemis II target date a little more than a year from now, that means Artemis III would be a little more than 2 years from now, which is not far away. So taking all of that into account, the big picture question is, what Artemis III mission options are feasible 2 years from now? For the last year, NASA has stated they aren't ready to talk about this, which makes this an uncertainty watch. There's a lot of questions and a lot of uncertainty, but we keep hearing about this mission concept of launching Orion to low Earth orbit to rendezvous and dock with a Starship HLS prototype. Starship prototyping is of course a long-term watch item, but last time I talked about feasibility questions for Orion and SLS. Although preliminary designs go back to the Constellation program, plans to actually implement the Orion for ISS crew rotations were canceled with the program. After the compromise in 2010 between President Obama and Congress, Orion was authorized to implement a beyond Earth orbit version of the spacecraft that would not need any of the more ambitious elements of the constellation plan, such as an Earth departure stage and a lunar lander that would get Orion to low lunar orbit. So Orion is not built to operate in LEO for very long, and there are questions about what modifications or upgrades would be needed for that. And even if it is feasible to implement them, is there any money to pay for them? And is there enough time to make those changes in less than 2 years? To illustrate this, prime contractor Airbus is going through final integrated testing of the European service module for Artemis III. It was supposed to ship to Kennedy Space Center in July, so everything is installed, and when it gets to Kennedy Space Center, it will be ready to be connected to the crew module adapter and then eventually the crew module. So who would pay for the modifications to the ESM? NASA, the European Space Agency, or a combination of those two? NASA gets its money from Congress. Would it need to get more in its budget? When the modifications to the ESM to support Orion in low Earth orbit were ready, how long would it take to disassemble ESM-3, install the changes, and then reassemble, test, and check out everything? Is that even possible in Florida, or would the ESM need to stay in Bremen, Germany and wait? Or would it be faster to install those changes on ESM-4? But before you get to the point of installation, how long would it take to design those modifications, build flight and test units, go through qualification testing, and go through acceptance testing of those elements? Or could you build something that could be attached externally to the spacecraft, like this sunshade concept from a Boeing study? Is that concept workable or acceptable under these circumstances? And there's the question of how you would attach it to the spacecraft, since this concept included a separate mission module docked to Orion that would not be a part of Artemis III. With so many unanswered questions, this is a rabbit hole that is easy to get pulled into. Stepping back, the big question remains whether any of these mission options is feasible 2 years from now, whether Starship can make it to the moon by then, which would keep the lunar landing mission on track, or whether there is an alternative that NASA can come up with quickly with limited resources. The Government Accounting Office's annual report on major NASA projects was published on Thursday, June 20th. The audit period ended in January, so we've gotten more updates on some projects since then, like Artemis II Orion. So here I will concentrate on new information or new context provided in the report. Talking about the lunar surface spacesuits that Axiom Space is developing to fly on Starship HLS with 2 of the Artemis astronauts to land on the moon, GAO reported that the date for the critical design review is itself under review. A human-in-the-loop vacuum chamber test needs to be completed before CDR can be completed, and the report notes there's 11 months of schedule risk to the test. The CDR was already the next watch item for the EVA suits, and Axiom is working to mitigate those risks, and we'll be watching to see when that test is completed. For the initial gateway capability, the co-manifested vehicle of the power and propulsion element and habitation and logistics outpost modules, the GAO report divides that development 3 ways. The modules themselves, since they are still being assembled and tested separately, and solar electric propulsion thrusters being developed for PPE. I got an intervening update from the Gateway program in May, but the GAO report provides some missing context to go along with the progress from the program. For the Halo module, the GAO report notes that repairs were necessary to the structure after welding was completed last October. That delayed structural load testing until around this timeframe, and we just saw a picture of the open-ended structure being moved for that. GAO reported that the Halo module is 539 kilograms above its mass allocation and could also be facing another mass increase due to a mistake in calculating the mass of all the wiring that will need to be installed inside. The structural load testing is the more near-term watch item, and mass growth is more of a long-term watch item. For PPE, the report notes that the changes to requirements are still working through the system, which has caused cost and schedule overruns. It also notes that as of February, The spacecraft mass was 170 kilograms over its mass allocation, and it noted for both the PPE and HALO modules the conflicting schedule estimates and plans. As I've said in past videos, the agency's baseline December 2027 launch readiness date is too late to support the planned September 2028 launch date for the Artemis IV mission. Gateway is only one of the pieces under development that will need to be ready to fly Artemis IV, but it will take a year for the PPE to propel itself and HALO from their insertion orbit to the Gateway's near rectilinear HALO orbit. A December 2027 launch date would mean the earliest the CMV would arrive in NRHO is on or after December 2028. That's obviously after the Artemis IV target of September 2028. The report phrases this another way, which is that Gateway must be launched by September of 2027 in order to be able to support the current Artemis IV target date. But the deadline date and the readiness date are based on different factors, and for now we'll be watching to see when Gateway is ready to fly. And to be fair, Gateway would need to launch earlier than September of 2027 because NASA will need to launch several tons of logistics to it before Artemis IV can fly. There will need to be some period of time after Gateway arrives in NRHO before NASA clears the first flight of Dragon XL to go. It might not be that many weeks, but that probably puts the deadline for Gateway a little earlier than that. On the advanced electric propulsion system thrusters that will be integrated with PPE, GAO reports that all 3 flight units are forecasted to be delivered to PPE prime contractor Maxar by July 2025. It notes an issue with the design of the wire harnesses is the biggest challenge to the delivery schedule. The harnesses were redesigned due to incompatibilities between the wiring and hardware on the PPE, and they were in the process of building a set for those for the second qualification model that needs to go through testing before flight. Qualification Model 1 is going through environmental qualification testing currently, and the second qualification unit will be fired for long duration as a part of wear tests. So we'll be watching to see when those tests start and finish, along with when the flight units are completed, acceptance tested, and shipped to Maxar. Similar to Gateway, the GAO provided important notes about Mobile Launcher 2 construction to go along with the recent Jack and Set milestone. The report notes that Bechtel is working to a November 2026 delivery date to Exploration Ground Systems, which will then have many months of verification and validation testing to conduct between the new ML, Launchpad 39B, and the new SLS Block 1B vehicle before Artemis IV can launch. Although November 2026 is the work-to date, the baseline commitment date has not yet been made public, and that will provide a good reference point to compare with this work-to date. The GAO report also notes something about the SLS flight computers, which will move from the core stage to the exploration upper stage beginning with the Block 1B vehicle. The flight computers and the RENU, the Redundant Inertial Navigation Unit, control the orbit insertion part of the launch with the Block 1 vehicle. The interim cryogenic propulsion stage takes over control from the SLS flight computers when ICPS separates with Orion. Beginning with Block 1B, the SLS flight computers move to the EUS equipment shelf, and they will control launch from right before liftoff all the way through translunar injection and separation of both Orion and large secondary payloads. The flight software, developed and maintained by the Marshall Space Flight Center, is being upgraded from the SLS Flight Computer Application Software, or FCAS, to the Exploration Computer Application Software, or ECAS, which will support EUS, Block 1B, and eventually Block 2. The GAO annual report notes that the flight computers will have an hours-long exposure to in-space radiation on EUS compared to the about 10-minute-long orbit insertion on the core stage. EUS takes over the roles and responsibilities that the United Launch Alliance ICPS has for the current Block 1 vehicle. ICPS uses ULA's common avionics that have flown these hours-long missions on Atlas V and Delta IV for many years. NASA is evaluating the environmental impact of radiation effects on the computers. On Friday, June 21st, NASA posted a new SLS Block 1B infographic, and I believe for the first time we see what EUS will look like, which is a white exterior rather than an orange foam exterior. As Boeing and NASA refined the design of EUS and the Block 1B vehicle, the upper stage and inner stage that connects it to the core stage have both changed in renders from foam to a white paint on the outside. This is something that has been noted verbally for a long time, and I double-checked about it when I was at Michoud Assembly Facility with NASASpaceflight.com last October.
But all of that will be white for EUS. It's all being painted.
Right. I mean, it's because it's an in-space. It's in-space stage. So
yeah, it's both for thermal and for space charging.
The last bit of orange above the core stage on Block 1B now is the two spray-on foam insulation sprays over the bolted flanges on either end of the inner stage. Thanks for watching as always. Click on the like button if you found this video informative. What's happening with the search for timely Artemis III alternatives and the SLS contract situation not only aren't going anywhere, but the more that you dig into these rabbit holes, the more questions there are while we wait for NASA to acknowledge them. The GAO report provided some useful context and perspective on Artemis progress towards lunar landings perhaps by the end of the decade, but there's still a long way to go, and this report is often a one-of-a-kind update each year. The next one of these updates won't be until summer approaches in 2025.